Okay, so my name is Eric, and I work for FIS Global. And as a side project, I've been working on this little SQL tracing and visibility tool called wuqiSpank. And before we get too far into this, could somebody collect business cards to see who's going to win the Raspberry Pi? Y'all know what a Raspberry Pi is?
Yeah.
Okay.
I don't.
Okay.
What is Raspberry Pi?
Raspberry Pi is a small Linux platform, and it runs on the small card inside this box. And it's great fun, great for tinkering. And, there are Linux distributions that are ready set for this particular footprint. You need your own memory card, and you need your own power supply, and you also need your own display, and your own HDMI cable. But outside of that, it's a great. That's right. Other than that, it's all, every bit of it. Every bit of it's all there.
It brings the random CPU.
I think it's a. Is it an ARM CPU? Yeah, it's an ARM. And this model has half a gig of RAM. So I'm sorry, where are the cards? Right here? Great. Okay.
Well, actually, let me give you this one. If you call out Jim's name, then that's me.
Sure. Hey, Tony. Okay. So like I said, wuqiSpank is an open source tool. You can go to this URL right here and download it right now and install it. And it's for tracing and visualization of all the hard work that our developers spend putting together their SQL statements that execute in the code. We'll talk a little more about this. You know, in George Orwell's Animal Farm, what's the quote? It's all animals are equal, but some animals are a little more equal than others. So wuqiSpank is very similar. It'll take SQL from any platform, but the Java platform is more equal than the others because you get live tracing with the Java application, and with other platforms, you've got to manually take your SQL, put it in a text file, and present it to the tool. So the whole purpose for this tool is to help developers finally start finding their own performance defects. And I think it's the exact phrasing, this bullet right here, but that was a presentation that I did 2 years ago at CMG. And I won the Mullen Award for that presentation, and I took it on the road to 8 different cities, 2 in Europe. And people loved to talk about the issue, about where we draw the line between how much work do performance engineers, what is performance engineers' responsibility for performance, and then what is developers' responsibility for performance, and the muddy line down the middle of avoid premature optimization that blurs the water. I'm sorry. It blurs the thought of where does the line fall? Who's responsible for what? So Jeff Boozen is a longtime CMG member and contributor and author, and he has this friend he's done some work with. His name is Peter J. Denning. He has this quote. It says, innovation is not brilliant new ideas, it's new practices adopted by the community. And I feel like this tool really falls into that. This has taken me a while to code, probably a year or two on the side. to put this together. But it's not a huge monolithic application. In my mind, the big benefit is when we all decide that we need a lot more visibility in our SQL statements. We'll talk more about this later, but every one of our current tools right now, we've got incredible response time and throughput and concurrency metrics on our SQL statements. And we also get lots of text, the actual text from the SQL statements. And that's wonderful, right? We need every bit of that. We can't do without it. And we pay money for decent tools that deliver that to us, in a stable way. But when we open performance defects, we often have, just crazy limited amount of information. We're looking at simple counts of this statement and counts of that statement. And we have to make crazy guesses as to what's going on behind the scenes. A developer sat down with a piece of code maybe for a month and decided, okay, what's my plan of attack? How is my code going to access all this data, right? I don't understand these tables. I've got to dig in and understand the relationships between all these tables, the parent-child relationships, and then there's other roles that tables play as well. There are static roles, right? You have data that doesn't change much, but it needs to be centrally available, like product data or maybe physical plant data. And if we query that furiously and somewhat accidentally, that can cause performance problems. So that's another issue that wuqiSpank aims to address. So wuqiSpank has a unique table-centric approach, like I've been saying. It does not yet have response time and throughput metrics, but that's certainly one possible direction that we can go. And in my mind, this provides a missing roadmap for understanding the direction of the developer on how they planned to go get their data. So the traditional metrics will show you specifically what is slow, right? But it will not show you the decisions that the developers made behind that, right? So during that month that developer was putting together their code, they made lots of decisions. How many invocations of the SQL statement should I make, right? Should I make repeated queries for small amounts of data, or should I make just a few invocations and grab larger result sets, right? And of course, there's lots of space in between there. So all those decisions, none of them are visible with our current monitoring tools, right? Because the table names, they don't show up anywhere in these tools. Once we get the table names in place, we understand the strategy that the developers had under the covers. So there's another problem that I have not seen people trying to address. So tons of teams are scared when they move from a very small development database into a larger production database, right? Where's the data going to grow? And how is our code going to behave, right? Are the indexes going to behave the same? So wuqiSpank makes kind of a first stride in this area, in trying to make it just a little bit easier, trying to get rid of some of the fear involved in moving from a small development database to a larger production database. So how do you find the root cause? And wuqiSpank's approach is to first understand a few basic anti-patterns, performance anti-patterns with SQL statements. And the paper that I submitted, CMG, just outlines three simple patterns that we'll talk about today. And then wuqiSpank makes it easy to recognize the signature of those anti-patterns in the visualizations that we'll see here in just a little bit. So anti-pattern number one. So I've been doing performance engineering for 8 years, and I was completely embarrassed that it was really just a year ago when I learned this particular term, SELECT N+1. And it's pretty straightforward. So instead of joining two tables that have a parent-child relationship, okay, so if you're not doing a join, often a developer will take a parent table and they'll say, give me 30 records from the parent table. And then they'll iterate through those 30, and for every one, they'll fire off a separate SQL statement to a child table. Okay? That's called the SELECT N+1 pattern. And the known solution is to reduce the query count by joining the parent and child table. Okay? And like all patterns, not every solution, fits the original problem, but it's kind of a generally accepted principle that you try to work with, and if it doesn't work, you punt and you find something else. So I was quite surprised to find so much research done on SELECT N+1, and these links will be available in my slide. I don't plan on going through these. So the second anti-pattern that I describe is very straightforward, and I mentioned it earlier. It's when you have data that doesn't change much, but the code furiously grabs the data over and over again as if it was going to change, right? And all that overhead can be eliminated very easily with caching solutions. cache is a popular one that our developers use in order to get rid of that issue in the Java world. And I know there are mainframe tools as well that are designed for that kind of caching.
Question.
Sure.
I think the cache is used on the app level, right? App server level, not the database level.
That's exactly right.
Right. So you're caching, you talk about the fetching data into the application layer instead of caching in the database, right?
That's exactly right. And what that does for you, it eliminates round trips. So, generally, just in my head, I always think if there's less than 10,000 rows in a table, Oracle is perfectly capable of loading that into memory and helping you avoid a hard hit to disk, right? But there's tons more overhead involved in database queries besides that. And maybe that same query will take a few milliseconds. And those few milliseconds add up. Tony Yan here and I both work on load requirements that are in the hundreds of TPS, sometimes the thousands of TPS, and those milliseconds add up significantly. So the third anti-pattern is uncached dynamic data. So this is uncached static data number 2, and we just switched that to uncached dynamic data. And this is basically when you have a customer table with real live data that's changing, but you continue to repeatedly query that, even though it's not going to change either in the small span of the workspace that your code's running. And wuqiSpank shows some really cool patterns underneath the SQL. It's when I started to see these visualizations, for me, they just pop. They're like, really? Okay, the code's doing that. That finally makes sense. After 8 years, I never understood any of this. I hope they do the same for you. We'll see that in a minute. So the known solution here is to reduce the query count by temporarily storing the initial query results so they're available later to subsequent code. And so I'm an object-oriented guy, right? I fell in love with that technology. I love it. It's important to me. And one of the tenets of object-oriented work is, oh my gosh, can we please stop replicating and duplicating code, and let's reuse some of this stuff, okay? Well, it is that aggressive reuse that has caused us lots of problems in this area. So when you have a series of developers on a database product who say, we've done the work for you, we have made all of this data model available to you, maybe via web services, something like that, okay? And the API is here for you to use, right? It's at your disposal, right? It's easy. Submit XML over that HTTP endpoint and the data is yours, okay? So that's wonderful, but we neglected to think how easy it is to misuse that privilege to have access to that API. And that misuse leads to this problem right here. So understanding the roles that your table plays is an important part of wuqiSpank's strategy to identify the root causes of these defects. If you have a villain to a crime, if you have a traitor, an accomplice, right, you want to quickly identify who those people are and in my mind, those are often the tables and the relationships. Okay, so this, for instance, is a wuqiSpank visualization, and you can kind of see the name at the top. I call these SQL sequence diagrams. And the sequence part of that name means that we start with the first SQL statement executed, and the next one down the line just continues in time sequence. So right here in wuqiSpank, this is what a SELECT N+1 looks like, the parent-child relationship. We went to the accounts table, we got an account number and some other data, and they said, yeah, let's go get some transaction history. And then we went one record at a time to get that history. And I guess the known way to refactor this is to join these two tables. You can get all of this work done, and it didn't finish here. There's lots more coming after that. You can get all that work done in a single query, and I have some very compelling results here later that do a load test and show specifically the response time difference between these approaches. And actually, I'll correct that. It's really the throughput difference that I focused on. There were response time differences, but the throughput was dramatic. So here's another role that a table plays, right? We talked about the voyage from going from a small development database to a large production database. And like I said, wuqiSpank's attempt to work on this problem is very small. It's just very minor. But still, it's a step in that direction, especially considering I haven't heard of people trying to solve that problem. And what wuqiSpank says is, let's get together as a team before the project, and let's decide, or let's make some guesses at what our high growth tables are. Okay, and let's flag them. wuqiSpank says red. Okay, so wuqiSpank is available as a web application for the whole team. We decide at the beginning tables X, Y, and Z are high growth tables, and we need to watch our query counts to the high growth tables. Pretty straightforward. So everybody sees the visualizations of their own SQL statements, all the developers, and they need to watch for the columns with red to make sure that they have very few invocations in those columns with the red. Does that make sense? And just an example, a traditional growth table is like a transaction history table. Of course, there are many other examples. Okay, so pop quiz. What happens when we move a functionally complete code base from a small development database to a large production database? And the answer is the software developers, they all go on vacation. Sure.
Yeah, I'm not DBA.
Okay.
But, I worked with like database. For your SELECT N+1 and patterns, can we use another way to resolve this? To create a view in database. You can view that you want these two levels. You still can query to that view, to fetch the data for you.
So Ben, that's interesting that you mentioned that, because I was on a team in the last 6 months where we did exactly that. Yeah, so that I like that idea. That helped us out. And in fact, we had Hibernate problems that we need to document. We were trying to get a left join to look good performance-wise, and it was executing so many more queries than we expected, right? Than we could configure it to run. So we figured out that it was the left join that was causing the problem. So once we wrapped that up into a view, Hibernate didn't see the left outer join anymore. So I was like, oh, okay, I'll do the right thing now. So it takes work to take care of those kinds of issues. So more on the issue of table roles. So red was for large growth tables. Blue, like a slow-moving glacier, is static tables. Okay, so you watch for the red ones because they're going to grow big, but you got to get your EH cache or whatever in place for the blue ones. Okay, same type of thing. We meet at the beginning. We say these tables are static, these tables are growth. We'll flag them. Developers will watch for them, and developers can take care of that themselves. Right? It's their code, and why should a performance team have to come after and clean up the mess that they leave? That's always been hard for me to understand. So when we talked about dynamic, uncached dynamic data, I mentioned that some of the patterns that I saw were very interesting, and this is the screenshot that I was talking about. And this is, I stripped the table names off the top, and the picture was a lot bigger than this. These two instances of this pattern, they went on for like 6 or 7 times. So if you looked at the full picture, this code repeated over and over and over again. And this is low-hanging fruit for optimization. That's what this is in our world. And also, this is an older version of wuqiSpank, and you'll notice that when you see this, you can't tell whether these are selects or inserts or updates or deletes. In the current version, we have the first letter of each word represent whether it's an S, an I, a U, or a D. Okay, so just to summarize real quick, we find the root cause. By first level setting, say, this is what performance anti-patterns look like, and these are known solutions for those guys. And then wuqiSpank goes in and it tries to identify the villains, the traitors, the accomplices that are, that play an active role in making that anti-pattern work in your code base, right? Because even if it's a performance defects, they almost have their own architecture to them, right? And these roles that I'm showing you, they play active roles in messing up your performance. So, I call wuqiSpank, I can't remember, what did I call it? Table aware. I can't remember what the term I used. For me, this is table dumb, right? You've got response time data. You can get similar throughput data, and you can get SQL text data, but where are the clues? Where are the tips for the anti-patterns? Where are the table names? I'm lost with all this stuff. I spend tons of extra time looking for that information, and when I spend a lot of money on a tool, I feel like that tool should do that for me. That's a duplicate slide. Okay, you've got a laptop, Andy. Do you have battery, and is it up and running? Okay, is anybody else? Okay. Let's take 5 minutes. Could y'all maybe get into a few groups or do it yourselves? I don't care. But what I want to do is I'd like you to come up with a sample set of SQL statements. Real short and real brief. Pretend like the schema already exists. I don't want to create table statements. Select this, select that, insert this, insert that, whatever. And email them to me, and we'll try to load them into wuqiSpank, and we'll see what they look like. Okay?
Sure, yeah.
I knew that looked wrong. Hazmat has a Z in it. God, I couldn't figure that out. Start from current slide. So what time is it right now? I don't have access to mine. 4:40. So let's go to 4:45 or so.
14.
Oh, 14. Sorry. Maybe I could put together my own. Maybe I'll do that. And you can skip the select list also. That'll make it faster.
Can you send us a really complex SQL as well?
Yeah, bring it on.
Something here that I use to create some of the reports in my
Yes, yeah, I'd love to have it. So wuqiSpank uses the Foundation DB parser, which is an open source parser. I'm sorry. So the Foundation DB is I think it started out as a NoSQL database, and they put a SQL layer on top of it. And they support, I don't know, it's something like SQL 9, or SQL 2003, something like that. And when wuqiSpank gets an error from the parser, like there's an Oracle vendor specific something, wuqiSpank punts and just throws up question marks on the screen. And wuqiSpank has done pretty well with complex SQL. It does subselects and other things. Maybe I've got 90% parse rates just anecdotally.
What's been your experience with dynamically generated SQL on basically SQL code generator?
I'm sorry?
Have you ever come across like a SQL code generator, something that dynamically creates SQL?
So something that dynamically creates SQL, like based on a schema, maybe?
Yeah, I mean it's got rules.
Okay.
It's basically, I guess the developer was trying to make it so that the true developer of the code wouldn't have to create SQL code.
Okay.
Just give you the data.
Gotcha.
It would just go ahead and it would create these abnormally long, complex
Right.
SQL statements. Like I go and do a performance test, and it's taking up 50% of the database.
So, there are object relational mapping tools like your Hibernate and your MyBetis.
Sorry. It's not finished, right?
Oh, so those tools will generate SQL for you. You point it at a table and tell it what operation you want, and it'll load that data into your Java objects. So yeah, and you're right, the SQL does get ugly and complex.
Yeah, I mean, this is like a homegrown one.
Oh,
It's even worse. It's not going to be commercial software.
gotcha.
Yeah, and then one on my head, that was the code. That caused the problem. It must have been 1,000 characters long. Like the SQL statement.
Yeah, I believe that.
Inner joins, outer joins, I don't even know how many tables it was trying to join.
Okay. Okay, so Andy, I won't be able to handle the @ signs, but let me see what I can do with it. I saw CompuWare in there, and that struck my interest a little bit, coming from the other side.
I can make that one look pretty small, but I won't. We have some that you need the Chinese scroll for. It bounces off the wall and comes down. I'm not teasing.
Okay, let's see what we can do. Okay.
This is the case where you gotta basically put the SQL into the.
That's right. So there's a right here. There's a specific folder, and any new files, not changed files, but if you dump new files into that folder, we'll be able to see those in the user interface that we'll pull up here in just a minute. Okay, Andy, I got your first one. Those @ signs, what's going to come of that? Yeah, that's not going to work. What the heck? We'll see what happens.
What is it?
Okay. Strike one. Strike two. Strike three. So that did not fly. So this is the wuqiSpank user interface. And each of these items here in the left column is basically all the SQL statements for a single, well, when we're Java tracing, it's a single round trip to a web server. But I just imported these as text files, and I did 3 separate text files, and I named those files AG1, AG2, and AG3, and it pulled those in right here. And we see the SQL count shows the number of SQL statements executed, and shows the number of tables. So if you had a whole set of queries, it'll count the number of tables that you see. Column count doesn't look like it's working. Doesn't look like it's working too well. So let me see what I can find here. That's not going to be good. Let me go here. So this is a more complicated set of SQL statements here. And you'll notice I flagged a few of these kind of haphazardly as being growth tables. And I have an example here somewhere that shows what it looks like when wuqiSpank doesn't understand a set of queries in a mix. Let me see if I can find that. Well, what happens is if there's a query in the mix, in this large set, wuqiSpank just throws question marks across the board. And I've started to work with the Foundation DB people a little bit and kind of started a dialogue on how we can add support for some vendor-specific things. So we'll be able to, I think we'll be able to make a few additions. But generally, we'll be able to support the common SQL dialects, and not the vendor-specific stuff. So, did anybody else have SQL that they wanted us to look at?
I did not see the result. Would you mind explaining the results you just read?
I'm sorry.
Can you just show us the results?
Okay, I walked through the whole, one whole gradient, like 10 black
Yeah,
And the other one had two,
That wasn't from the SQL you imported though, right?
that's right. So the SQL that Andy sent me, there was lots of vendor-specific syntax in there, so none of it came through. Okay, so that's an important limitation to understand in the tool.
Sorry for challenging you with that. I'm just interested because this query was actually created by one of my colleagues, and I could not believe when I saw it. Like he created it for a report that I wanted.
Nice.
He's an expert, or very creative, let's say that way.
So when you have text like this, again, the first query at the top is the first one that runs, and they flow sequentially down the screen. And if you want a little more detail on what's happening, you can just look at the full text of what's going on. So this is not, this is not a trivial SQL statement. Lots of joins happening here. And with a native Java trace, and we might have to work a little bit to get that, you can show the entire stack trace for the exact line of code that executed that SQL statement to the database. And that's really helpful for debugging. But this was imported manually, so there's no stack trace. Okay. Anything else anybody wants to look at before we move on? So here, for instance, this activity in here is definitely something that I would consider low-hanging fruit. This whole pattern right here happens repeatedly. So we join these three tables, hit that one individually, come back and do two more individuals, and that pattern repeats there, here, and it keeps going down the screen. And like I said, we'll have results here from a separate performance test that shows the implications of the chattiness of this kind of an approach. So let's jump back to the presentation. Okay, so let me try to get my tracing application up and going. And I've kind of shown you some of the more complex SQL there. Okay. This is going to take a second. I need to start up my database. So, I'm not sure if you've seen, but I've done small amount of unit testing on DB2 and Oracle, and MySQL and Postgres, and HSQLDB. Whoops, I need to start up. And let's see how we're doing. Okay. Okay, so that's not looking good. Maybe we started up before Postgres was ready. Let's go to my cheat sheet to make sure I'm on the right place. Oh no, looks like I had the wrong port number. Or not. Okay, what's happening here? So you can see a little bit here on the screen. This is one of the underlying technologies that's used. This API uses java.lang.instrumentation to capture method invocation events from a remote JVM. So there's ASM bytecode that's added. wuqiSpank says, I'd like to see JDBC events from this class and another class. And this agent puts in ASM bytecode to capture those events, and then they're sent back over the network to wuqiSpank. And let me peek at the log real quick. Okay, so my database is having problems. Okay, so we can spend time on that later. So I'm going to jump back to the presentation. So why bother with all of this? Are the optimizations that I'm looking for of much benefit? So, I mean, I've asked that question myself. And we do have to ask the question about premature optimization, right? My wuqiSpank user interface does not have any response times and throughputs right now, but I'm pretty much going forward with a recommendation that I think this kind of optimization, it can be done in development at a very minimum to start to address the lowest hanging fruit. And I've got some examples of this lowest hanging fruit here in just a few slides. So who needs wuqiSpank? So I like this graph, although it's very painful, right? This was a few months of my life this summer, and this flat line here is basically I'm joking, but it's a near heart attack on my part, where we went for 10 days without any throughput jump in our application. That's very, very painful, not to be able to resolve any performance defects and get higher. So that was pretty much for unrelated purposes. But this is a long haul. This application started out at 1 TPS. So when we loaded a single user, all of a 4-core CPU was consumed. And this is a long, slow haul here. This is several weeks of work to get all the way up to 250 TPS over the course of a few months. And in my opinion, more than half of the work that we did during these months, they're all things that developers could have and should have been doing on their own. And in my mind, wuqiSpank provides the visibility for developers to see, oh, okay, I was getting a little query happy here when we sent 2,000 queries to the database. I guess I could have done something about that. And going that next step further, wuqiSpank says, okay, here are the table names you were hitting. There was a select N+1 here, and you flag this table as being cached, and you don't have any cache on it, right? So wuqiSpank goes to that next level. So this was a Microsoft slide that I found where this application, for a single click of a button, invoked 2,256 SQL statements in a single click of a button, okay? And we see some of that also. And these obvious kinds of defects, these are the low-hanging fruits that I feel like developers should be responsible for. I think it's a waste of time for performance engineers to be cleaning up someone else's issues, and mostly because the time is spent to write the code, and once the code has been written and somebody else discovers the defect, the code has to be unwritten. Of course, putting EH cache in place is not terribly difficult, but retreating from some of these other scenarios, let me pull up. Let's go back to wuqiSpank. Whoa, that wasn't what I wanted to hit.
What did you use to apply
This testing was all done on JMeter, okay? So it's not an easy retreat from this work. This took someone a lot of time to put all this together. And how do you reverse all this, right? That's a rewrite. That's what that's about. So I think putting the visibility in the developer's hands can help us avoid the rewrites that are required to give us the performance that's necessary to go into production.
So do you use JMeter from an end user perspective, or do you just connect up with SQL and throw SQL statements?
You know, that's a real good question. The question is, do you use JMeter to apply load to your web application, or do you use JMeter to submit SQL statements over JDBC to the database? And everything you've seen here, where JMeter is hitting the web application. But often I wonder, you know, I second guess the data that I get from a performance tool, and I say, how much of this problem is the SQL statements and how much is the code? So on a few different occasions, I've taken an entire, you know, bulk batch of SQL statements and I've put them in JMeter and said, you know, we have a problem right here just with the SQL statements. You don't have to get Java involved to, you know, to take the system down. The SQL can do that all on its own. So I think that's a great approach to do that.
Well, I think based on what you're trying to say, you're saying, hey, use the wiki tool.
wuqiSpank.
Use the wuqiSpank. Give the wuqiSpank tool to the developers, or give a system administrator, or a systems engineer working back to the developer. Well, I think the add-on component of that is to also teach them the JMeter. So that, I mean, they should essentially be able to test out a lot of these things.
So I really like where you're headed there, and here's why. Where's my? So one kind of enhancement that I've considered is generating a JMeter plan from these SQL statements. So it wouldn't take too much development to take all the SQL statements, put them in a JDBC file that push JDBC requests, right? Not web requests, but JDBC requests, and said, okay, here's the performance of your SQL statement, and essentially here's the mess that you put together. So I love it. That's a great idea.
I'm just curious about, say, if you only submit this SQL statements without data, right? So you can get response time for the executing the SQLs. How?
No, hang on. That doesn't sound like it's the case.
No. Okay.
So this application right here, we had the best production data I've had in many years. You know, so we had you know, hundreds of millions of rows in certain tables, and it was decent data.
Because when you execute his query, right?
Right.
Of course, it's some syntax proprietary to the vendor, but I think you're trying to show us that if you execute his query, we'll give you some results.
That's right.
So that's my question, guys. The result, because I don't think his query will access your data.
Okay.
Right? That's my question.
Yeah, I think I do have.
Okay.
I think I do have some clarifications to make.
Okay.
So my work, and I was talking about a project that took a few months. That's where we were taking JMeter, we were applying load to get to a particular throughput. Okay, that was a system that needed to perform a lot better than it was. wuqiSpank, it will not work under load right now. Maybe in the future, but there's more tuning to be done in wuqiSpank before we can apply load. So wuqiSpank is for onesie twosie tracing. Right now, if you put load on it, it'll bring the system down.
And essentially, at this point, you're just trying to find patterns.
That's exactly right.
Patterns is not a problem.
That's right. You're just trying to find patterns for problems.
Fix those, and once you're done with those, then you can go ahead and do your load test without wuqiSpank.
That's right.
You can apply your load test and see how you do it.
So, like with this right here, this kind of thing, this will show up immediately, right? You'll get this kind of data, and you will see that developer's month of work on what they put together. What were they thinking, right? You will see all the gory detail. And if they want to retreat from any of those details, the details will be right there on the screen for you, right? Yeah, Tony.
So how your tool will know, what table is static, which table is the growing table? If I just give you some arbitrary formula, you need to set up something to
Right.
know.
So here at the top of the screen, I'm saying that the teams are responsible for flagging which tables should be red for growth tables and blue for static tables. So there needs to be a meeting at the beginning of the development project, kind of like this first bullet says, right, where the teams go in and there's wuqiSpank configuration, and the developers will say, okay, we've decided X, Y, and Z are the high growth tables, and A, B, and C are the static tables. And you configure that information on your central wuqiSpank instance that points to a single development server, right? And everybody on the whole team gets to see data from everybody's requests. Okay, so if you have one development server, right now the default configuration is to put wuqiSpank on that same server, although you're capable of sticking that on a separate server. So once you have your central development server, you stand up a wuqiSpank server, and the whole team, the management, the BAs, and you talked about maybe having a system administrator look at that. I shared this presentation with one of our DBAs at FIS in the last few weeks, and she said, oh my gosh, I spend, she spends months putting together a schema, right? And in her head, she's thinking, okay, the developers are going to use these relationships here and those there. These will be growth tables. These will be static, right? And she's got a whole plan in her mind. And she says 9 times out of 10, the developers, they do something completely different, something she didn't expect, okay? wuqiSpank would be beautiful for confirming, A, did the developers, I suppose, follow instructions, if there are such a thing that come from DBA? Did they follow instructions? Or B, maybe we could validate that there were problems with the data model in the first place, because look at the crappy SQL we have to write in order to get to the data. So I think the tool has value from a validation standpoint. I've been talking about validating the developer's work, but it could be helpful for the DBA to validate his or her own schema. Okay, let's get back on track. Okay, so I asked a few slides ago, why do we care? Why is it important to spend this time? And what I have for you in the following few slides is, so here is my personal experience with just a few of the kinds of problems that we see. And again, these are just very exaggerated ones. Right here we have 82 SQL statements with a single click of a button. And so 16, this particular request went to the exact same table 16 different times. Okay, it's that kind of optimization that I'm talking about, I'm looking for. But people out in the industry at large have chimed in on this issue as well. So here in 2003, more than 10 years ago, Martin Fowler says, do y'all know Martin Fowler? Show of hands. Okay. Martin Fowler, he has 2 books on the gotta read it technical book library. There was a Stack Overflow question that said, what book must every developer read? And his book showed up on that list twice. Okay, so he's written on object relational mapping as well as a lot of application architecture. And back here 10 years ago, okay, he says try to pull back multiple rows at once. And he says specifically never do repeated queries on the same table to get multiple rows. So that's exactly what this is right here. You're making repeated queries to the same table for multiple rows. Okay? And Martin Fowler was preaching this 10 years ago that that's not the right way to go. Okay? So Andy Grebner, did I pronounce that right? Close enough? Is right here in this room. And in 2010, he published this blog post on behalf of Dynatrace, for whom he works. And Too Many Database Calls was #1 on their list for working with Zappos and Monster.com. This is a D-Zone article. Too many external system calls are performed in a synchronous and sequential manner. Same kind of thing. That was #4 on their top 10 list. Dynatrace, again in 2013, they said, you know, there are a lot of client-side issues now, but on the server side, too many calls to the database is still the #1 server-side problem. And then here's App Dynamics. This was very interesting. Here they specifically reference the SELECT N+1 problem. And if you read this article, the author says, here's how to use our tool to go find the SELECT N+1 problem. And he says, go look for the parent table. And then go look for the child table. Okay? When you have 82 queries, how much time is that going to take you to go find the parent and child relationships in all of that text? Okay? App Dynamics does not make it easy for you to go find the parent and child tables at all, in any way, shape, or form, right? You've got to go manually dig for that information. So here's this vendor saying, you need to go fix this problem. It's a SELECT N+1, and you're going to need table names. And you know what? You're going to have to hunt for them yourself. I don't care how much. I don't care if I don't care how much SQL you have. You're going to have to go hunt for that SQL, those table names inside the SQL text yourself. Java performance tuning. It's had at least a second revision. I'm not sure about more, but this book came out in, I can't remember, I think it was early 2000s. And Jack says there are ways in which you can paint yourself into a corner. So the only alternative is to throw it all away and start again. Okay, so I just wanted to bring this up. I'm not the only one who says that, look, if we ignore things in the beginning and we get so far into it that we have to rewrite it when we're finished, it's gonna cost too much. It's gonna take too much time. You're gonna have 3-month projects trying to go from 1 TPS to 250 TPS. So the cost of retreat is very high. So I've mentioned a few times that I did a little experiment to figure out, well, am I making a fuss about nothing, right? How much benefit do you get by avoiding all this chatty stuff? So this blog post of mine details the work that I did, and I wrote, I implemented a simple service. I've actually shown you some of this code, some of the wuqiSpank visualizations already from this. So I took one service. It was basically an account inquiry that grabs some account data and it grabs some transaction history data for that account. Okay, my account inquiries said, give me data on 5 accounts. Each of those 5 accounts had about 25 history records. So roughly 125 records total was what came back in the client request. And this, I just implemented just a simple XML over HTTP request. And I've already been beat up about this a little bit. I should have made this graph a lot more standard, a lot more boring, but the results were so interesting that I just repeated them over and over and over again. So I mentioned that I had 5 scenarios. So that same scenario, right? Grab an account and grab its 25 history records. I wrote 5 different variations of that. One was extremely chatty, so chatty y'all would laugh if you saw the code, and it's out on GitHub, so you can download it and run it yourselves. It's kind of silly. But then I wrote one that was ultimately chunky, right? So those are our opposite ends of the spectrum. You're either very, very chatty, or you're very chunky, or you're somewhere in between, right? So I did 1, 2, 3, 4, and 5. One had the fewest SQL statements. I tried to keep the numbers in line. So 1, 2, 3, 4, 5. 1 had the fewest SQL invocations, not necessarily statements, and 5 had the most. Okay, so each of these lines here, this is 1 minute right here. So this is scenario 1. So this is the chunkiest, and it ran for 1 minute, and it got the highest throughput. Okay, way up there at the top. Then the test moved on to scenario 2. So it's really just one scenario running at a time. But it alternates, it goes through. And these are our throughput numbers. So these numbers up here at the top, the 360, these are roughly 30% higher than these. So in my experience, these scenarios here, these 3 and 4, are the most common patterns that I see coded in software. And you can go to this blog page, and it'll take you to the GitHub site, so you can see all the dirty details on these 5 different scenarios.
First option was chunky, and the second option was chatty.
So this is scenario 1, 2, 3, 4, and 5. So the lowest number scenario has the fewest number of query invocations. That's right, so that's chunky. So you're getting a lot of data in a small number of requests. And how much time do we have left?
-5.
We're over, okay. So I guess I'll get my tail moving. What else do we have? So these are the wuqiSpank visualizations of these. So if you look at this data and you consider application performance monitoring data, looking at this also, this is JMeter data. You're going to get response time. You're going to get throughput. You're going to get concurrency. Gosh, you name it, right? There's tons of data we can get. But you know what? You don't get this. This shows you what is going on with these different scenarios. Scenario number one, okay, so we have two tables. This is the schema is from the Postgres PG Bench database. It's designed for performance benchmarking. And, you know, I had 100 million rows in some of these tables. But when I thought about it, that was just a waste of time. You know, at FIS, we have some freaking ninja DBAs that can make things, you know, 5, 4, 3, 2 milliseconds, super fast. So what's the difference between running with a super high-tuned database and running with a small, you know, unrealistically small database? But anyway, so these are the different scenarios. Scenario one made a single query with these two joined tables. That's why the thing was so fast. It just went once. Of course, you've got the JDBC fetch size, which I did not include in these tests. If you don't know, the fetch size is an under the cover flag. I'm sorry, it's a count of how many records come back in your result set. So if your application code just makes a single query, under the covers, if your fetch size is real small, you could be going back and forth many times and you wouldn't know it. I did not include, I just took the default fetch size for the Postgres JDBC driver and I moved on. Okay, that's future work. So, so here we go in scenario two. It shows that, look, we grabbed all the accounts from the account table first, and then we grabbed all the transaction history right after that. Okay, scenario three was a little bit different. We got all the accounts first. So the scenario was, here's 5 account IDs. Go get me inquiries on all these. Okay, so scenario three, it got all 5 accounts in one go, and then it made one query to transaction history. It said, okay, account 101, give me your 25 records. And then iterated 5 times through that, or I guess 4 more times through that. So wuqiSpank tells you what is going on, what these scenarios look like. It takes lots of tracing. You know, tools like AppDynamics and Dynatrace, they plug you in to the lines of code. So you can go through and you can trace that code. But in my opinion, this tells you a lot quicker what's going on. You're looking at the strategy of what that developer was going through when they coded these components. Questions? Ready to go? Okay, so I'll try to finish quickly here. In my opinion, some early tuning is warranted when you're addressing the worst server-side performance problem in enterprise software, and I feel this is that problem. Early tuning is warranted also when the cost of retreat is very high, which it is in this case. When the problem is easy to demonstrate, my chunky outperforms chatty experiment, in my opinion, shows that it's easy to demonstrate that chatty performs much worse. Some early tuning is warranted when kind of like when the response of development teams to identify the problem has been meager, right? 2,000 queries out of your code for a single click, really? You think that's okay? So this is more whining and complaining from an SPE person, but I'm not convinced we have the right staffing model for performance, right? Why is it that we have these small teams of technicians that are cleaning up the big problems of these really large teams? It doesn't make sense to me. What's that? Okay. And then, so somebody in the back says they agree. I'm not convinced that we have the right tools because I really want to see this. I want to see this in my tool. It tells me more about what's going on in the code quickly. And once you flag a defect with some other tool, what are you going to do? You're going to go research this. You're going to go find this exact data, and wuqiSpank gets it for you. And of course, performance is placed in the wrong part of the software development lifecycle, right? As you get closer to production, you want your risk to kind of trim down. But here, we've planted the performance efforts at the very end of the cycle. So it's high risk going in here and doing this retreat, right? Oh, the code fails, we need to rewrite it, so let's retreat. You're risking introduction of functional bugs, all kinds of changes going on. So right when you want the risk to be lowest, when you're going into production, the risk is the highest. Does that make sense? That does not make sense. You know, I feel like I'm screaming at my TV screen, you know, saying, oh my gosh, why isn't this right? You have a question, or were you just moving? You know, I feel people in our company, at least, perceive performance efforts as being expensive, complicated, and extravagant, almost a luxury, right? And I wonder whether it's because, you know, our model is wrong, right? Whether we have the wrong people working on this stuff and we've placed it in the wrong part of the cycle. So as a conclusion, open source visual tracing tool, wuqiSpank provides a roadmap for what the developer did when they're writing their code, saving lots of time for research. Chunky outperforms chatty. We already know that the chatty pattern doesn't perform, so why wait to optimize it when the cost to fix is pretty low, choosing chunky over chatty? Some platforms are more equal than others, and wuqiSpank just makes the slightest nod towards a safer voyage between small databases moving to larger ones in production. So yes, we must avoid premature optimization. I really do believe in that. But it doesn't excuse developers from all performance concerns. I feel like we need to draw a more specific line about what developers should do on their own and what performance engineers will do. And so I'd appreciate your help circulating this idea if it interests you, or if you think it's helpful. Take it to your own development teams. Ask them if it would be helpful. I'm not laying down specific requirements on what you should do. I want to provide the visualizations to allow them to get the lowest hanging fruit. That's what I'm headed after. If you've got 2 seconds, I've got these features that I'm considering. Do any of them look more attractive than others?
The last two for me.
Okay, anybody else? And if any of y'all, I think one thing that could help spread this idea, if y'all download it, install it, run it, you know, It's got problems. It's a young tool. I couldn't do any of Andy's SQL, right? But I think this idea is still worthwhile going forward, even though it's young, even though it has issues. So write a blog entry. Tell me about the problems. Send it to Reddit or to Slashdot. Let's try to popularize this. Let's try to get people involved. And thank you very much.
Well, Eric, thank you very much for giving this presentation. And this certificate is for you to thank you for speaking at CMG.
Great. Thanks, Peter.
Okay.